Algebra 1 Notes, 5.3, Part 2, Slope-Intercept Form of a Linear Equation. All right, remember that we're working with the equation y equals mx plus b, that is in slope-intercept form, where m is the slope and b is the y-intercept. Where does it cross the y-axis? So we're first going to write the equation in slope-intercept form, and then find the slope and the y-intercept, and then graph it. All right, so if we look at this one, it's a little bit different than the ones that we had in the previous section because those were already in the right form, y equals mx plus b. This one, we need to solve for y. Solve for y. So if I want to solve this for y, what I can first do is move that 2x to the other side. I'm just going to write it down here. So minus 2x minus 2x. So we get 3y equals. Now here's where I would write the negative 2x first. So negative 2x. And then is 12 positive or negative? So look at the sign in front of the 12, whether I should put a plus 12 or a minus 12. 12 is positive. There is no sign, it's just a positive. All right, finally, we can divide by 3. So we get y equals, this we can just write as a fraction, negative 2/3 x plus 4. All right, so now we can see that your slope is negative 2/3 and your y-intercept is 4. So when we graph it, start with that y-intercept of 4. And then from there, our slope is negative 2/3. So we're going to go rise negative 2 and run 3. So rise negative 2, down 2, but positive 3. So 3 to the right. Down 2, positive 3 to the right. Or, so I was doing down 2 and 3 to the right. We could also do up 2 and 3 to the left. So if I go back to my original starting point, we could go up 2 and 3 to the left. Okay, and then go ahead and grab your straight edge and connect the dots. And then don't forget to put the arrow on at the end to show that it's going to keep going forever. There we go. All right, let's try another one. Example 2. Negative 4x minus 5y equals 20. Okay, so solve for y by adding the 4x. So it's negative 5y equals, and then again, I like to write the x first so that it's in slope-intercept form. So I'm write 4x plus 20. And then last step, divide by negative 5. So you get y equals, and then again, remember these number parts, you just pull it out front. Negative 4/5 x, and then 20 divided by negative 5 would be negative 4, so we're going to go minus 4. So our slope is negative 4/5, and our y-intercept is negative 4. So we're going to start down 1, 2, 3, 4. And then negative 4/5 slope. This one's kind of tricky because if I go down 4 and right 5, it kind of goes off the graph. So instead of kind of figuring out where that point would be down here, think about where it would be up here. So down 4 and right 5, we could go up 4 and left 5. So it'll be somewhere like that. All right, so then take that straight edge, connect those dots. To show that the line is going on forever. All right, let's go to the next one, example 3. All right, so we look at this equation and we're thinking, okay, we need to put it in slope-intercept form. But what we notice is that, for example, 3, it's already in slope-intercept form. We wanted it in the form of y equals mx plus b, and it is. So go ahead and graph that, and then I'll put the answer up here in just a minute. All right, so your starting point is the b down 3. And then your slope's 4. Remember, if it didn't have a denominator, we can put it over 1. So if you forgot that, go ahead and graph it now. About 30 seconds here. All right, so our slope's 4 over 1, so we can go rise 1, 2, 3, 4, and run 1. Rise 1, 2, 3, 4, and run 1. Also down here, we can add a point down 1, 2, 3, 4, and left 1. It kind of hangs off the graph there. All right, connect those dots. And again, make sure you're adding the arrows at the end to show that that line is continuous. It keeps going on. All right, why don't you guys try and work on example 4. If you couldn't find a starting point, you want to solve for y. All right, move the x to the other side. So think about how you would do that if you haven't got that figured out yet. And then remember, you want to write that x first. So the negative goes with the x, minus 3x. 8 didn't have a sign in front of it, so that means it's a positive. Last step, get rid of the 2. So rewrite your equation and see if you can graph it out. So we get negative 3 halves x plus 4. So think about how we would graph that. All right, so your slope is negative 3 halves. So you want to go down 3 and right 2. Down 3 and right 2. Go ahead and plot as many points that will fit on your graph paper. It's not going to be that many. Don't forget to do the point on the other side also, up 3 and left 2. Now it kind of hangs off the graph, so if you didn't have that point, that's okay. But do think about it if it fits. Connect the dots. Now, if your dots aren't making a straight line, check your counting, because you could have maybe plotted one a little bit off. Maybe you didn't count right for your rise over run. All right, let's go to the next one. Example 5, y equals 2/3 x. So we can say, all right, so this one, think about what is your slope and what is your y-intercept. Now, one of them is 0. So think, which one do we know and which one is 0? All right, so you know the slope because that's the one that goes with the x. And we're looking for the y-intercept. Since there isn't anything there, it's just 0. So we're going to start at 0, 0. Slope 2/3, rise 2, run 1, 2, 3. They're both positive, so we're going up and to the right. Okay, or we can go down and to the left. Why don't you plot the points that go on the other side? And then go ahead and check them with the board. Alrighty, let's move on to example 6. Y equals -4. So remember this one, the y is always equal to 4. So there is no slope. The m is actually 0 on this one. Since it's y equals, it would be like 0x minus 4. So 4 is the y-intercept. And your slope is 0 and your y-intercept is -4. Sorry, -4. So go down 4. There's your y-intercept. Now, if I want my y value to always be -4, think about it. Your x could be anything, but your y needs to be -4. So you could actually just make up a couple points where your y is -4. We could do like -2, -4, 1, -4, 5, -4. So if I plot those, it's just going to follow along that horizontal line. Okay, so a y equals line is just a horizontal line. Now the next one's going to be an x equals. We didn't have one like this yesterday. So if there's no y in it and it's just an x equals, it's going to be the one that had the undefined slope. So it's going to be a vertical line. So example 7, x equals -4. So again, you can use that same thought process and think about your x always being -4. And what would the y be? We don't care. Y can be anything, but x must be -4. So if you go on the x-axis, you can plot that point at -4. All right, so you could do like -4, 2, -4, -3, -4, and -6. Well, what's going to happen is it's just going to plot these points that make a vertical line. So if I want x to always be 6, then it's always going to be left, or x to always be -4, it's always going to be left 4. So it'd be this line. All right. Last one, I believe. Oh, no, that was it. Okay, so that's the last example. So now you can work on the 5.3 Part 2 worksheet and have that done for tomorrow.